today I have the honor to be joined by Mr. Mark Engel, the President and CEO of Phagelux AgriHealth. And you will learn a lot of insights about this very novel biological solutions for bacterial disease control. Well, thank you, Mark, very much for the opportunity.
Thank you.
To start with, could you please to introduce about Phagelux AgriHealth?
Sure. So we are a Cayman company.
Uh-huh.
We have got subsidiaries all over the world, and we're developing products based on phage technology for agriculture, for food safety, for animal health, and some specialty products. In cumulative, we've got about 16 commercial products, and we expect to add 3 more this year. We've got now 3 factories, 2 are in China, 1 in the U.S., with additional ones planned for end of this year, beginning of next year, in India and Brazil.
Wow, that's very fascinating. But by the way, congratulations on your first feed product registered by ICAMA in China. That, you know, I was born in a farm. I believe the farmers in China will be benefit about this technology for bacterial disease control.
Well, thank you.
Yeah,
Thank you.
Thank you. In the past few years, I mean, the phage only been maybe the last decade. They have some exciting advancement. So for your work or in your company, what are most exciting either scientific or technical advances your team has working on?
Technical, I think when you get down to things that are most important for phage and what we're much better at today than we were 10 years ago. One is understanding the phage, genomically, etc.
Yeah.
And these sort of things are real, whether it's genomics, whether it's high throughput screening, whether it is understanding gene sequences. All of these are important in order to help build a cocktail of phages that manufactures well.
Awesome.
This business is primarily about low-cost manufacturing. If you cannot manufacture products inexpensively, then you're not going to be able to get return for farmers. And you know, farmers care a lot about their profits.
The cost, right?
Yeah,
like
exactly.
Like we mentioned the other night, efficacy, yes, we will focus on that. It's important, but
obviously efficacy is important. But when we develop a product, we develop it in a much different way than an academic person would think about product.
Yes, yeah.
So we develop it really thinking about how can we keep the cost of goods as low as possible.
Yeah.
This means manufacturing. How can we get the highest titers?
Yes.
Sometimes things look great in the lab. They kill everything. And you put them into the fermenters, and it's a disaster. And so we have a lot of technology today that helps us predetermine whether it's likely to be able to scale to high titers.
I see.
If that's our first step, high titers, you know, you're talking about large fermenters. If you did everything in a large fermenter, you'd probably go bankrupt.
Yeah.
So we do a lot of things in terms of the high throughput, the AI, et cetera, that helps determine the likelihood of something to be able to scale.
I see.
But we're not just looking at high titers. Before we even look at efficacy, we look at 2 other things.
Which are?
One, can that phage be stable, and particularly stable at room temperature, maybe even a little bit warmer than room temperature, for an extended period? Because from the time the farmer buys the product to they use it, normally is quite quick, but it's not going to be tomorrow.
Yes.
So as a biological product, it's important to be able to have a long shelf life, even at room temperature. And this is one thing that we do that really differentiates us from other people, is the formulations we use to get long-term stability. The other thing that is important is that the product must be able to be dried. Sometimes
granular.
Yes, sometimes you want to ship a product wet, particularly if it's a close location. But sometimes if it's far away,
Yes.
The farmers want to get the product as a dried product, or distributors, or whatever part of the value chain you're shipping to. And so if you can't dry the product efficiently, then it's also no good.
Yeah.
So we go through those 3 steps before we even look at efficacy.
Wow. So I believe when you guys, as expert in this space, when you develop, of course, different phage have different feature, right?
Yeah.
You would think this from the same bacteria species, they will behave the same, but probably not.
No,
right?
definitely no.
Like I learned from your talk, right? Some of the phage is just perfect always, right? Once get in, it's perfect, right?
Yeah.
Never be allergic.
Yeah.
Even they're allergic, but when you try to stabilize them, they may be not.
Correct.
Right. So that is interesting. I know. Probably this is my next question is the main bottleneck in developing this technology.
So obviously it takes some time to develop a product. And once we've figured out that process of what is a good phage from a commercial perspective, we then have to, our next step is it efficacious? And we want to build a cocktail. This gives the bacteria almost no chance to mutate. So we try and get about as close to 100% coverage as we can. And we don't really mind as long as, whether it's 3 phages, 4 phages, 5 phage cocktail to get us there.
Wow.
As long as it's high titers, we can afford to do that.
This cocktail, if may I ask, is they can be targeting different bacteria species,
Correct.
right?
Well, I mean, so we have two different sorts of products. We have one product that, and let's just take an example of salmonella.
Salmonella, yeah.
So we have a product where we're targeting all species of salmonella.
Yeah.
No problem. But for some applications, we may want to have a second bacteria
yeah.
covered. So again, we're trying to get as many species as we can covered, and then we have to make sure that all of the phages are happy together.
Yeah.
Sometimes you have a phage that just doesn't want to play with the others.
Not compatible with each other. You would think they should be the same, right? But they're not. Interesting.
Well, some of your neighbors, you may wish you were not your neighbors.
You did a very nice analogy this morning in the talk. Different people just kept me, put them in the team, right?
Yeah.
But fascinating to learn that from your talk is phage products is compatible with some other biologicals or chemicals the farmer are using. Right?
Yeah, in fact, it is much more compatible often than people think. The easiest way I can kind of think about it or explain it is, what we're trying to avoid is resistance, the bacteria changing.
Yes.
And generally speaking, bacteria are funny. They can put up one defense at a time. So if you're putting if you're putting a chemical at it from one side and you put a phage at the other, you get a synergistic effect.
Yes, double mode of action.
Yeah. And even sometimes if the chemical is no longer working and you add the phage, sometimes the chemical starts working again, which is kind of interesting.
That's interesting, right? I know I mentioned I'm working a little bit on the phage in the citrus greening bacteria. They have a wholling-like protein or gene in the phage genome.
Correct.
So this is probably one of the genes you guys try to look at, right? Look at the phage genomes.
Yeah, there's a lot of things that you're looking at to get an efficacious phage. I don't think that there's necessarily one thing, although if you've done it enough, you can look at it under a microscope and say, oh, this one's likely to work.
Yeah, the good thing is in the phage genomes, they are not that big, right? You don't need to do a lot of deep sequencing.
No.
Based on your knowledge as expert in this domain, if give you a phage, you sequence them, you know which ones you should engineering them or doing some work.
We don't engineer anything.
Oh, just, okay.
We can. It's very easy to CRISPR a phage.
Yeah.
But regulators don't like that.
I see, just the native ones don't do.
Yeah, and the other thing that's kind of interesting is, generally speaking, the native ones manufacture much better.
That engineering wise, you are right.
Yeah.
You are right.
And again, we're all about about high titers and low cost of goods.
You didn't mention, but in the morning, your talk is you like biology. You know, biology against mechanisms, right?
Yeah.
It's from external, right? That's very interesting.
Yeah, people ask me what I like most about the company, and my answer is something that people don't expect.
Which is?
My answer is, we see bees on the farm again.
Bees on the farm is again. Okay.
Yeah.
Which is good.
Which is great.
We want to see, right?
That's what we want to see.
Yes.
But it's not necessarily what people would think about in terms of a motivator for a company.
Yeah.
But what we see is if the farmer can get a better return,
Yeah.
great.
Yeah.
If the farmer can pass on a better farm to the kids, great.
Yeah.
But the bees mean it's working.
Yes. That's a good example, right?
Yeah.
Just make the systems better.
Yeah.
Yeah. Well, that's interesting. Well, that is coming to my next question, Mark, is how do you see the phage technology will shape the crop protection in the next 5 to 10 years?
I think today we know less than we will 10 years from now. And by that I mean we're beginning to understand how phages work in real life. How they work in the lab is actually very different than how they work in the field.
Yeah.
For reasons we don't quite yet know why. But you can take an inoculated tree
Yeah.
and a natural tree.
They're different. That bacteria type are different too.
Everything should be the same,
Yeah.
but it's not, and our products work extremely well in the field. But when you inoculate the tree, it doesn't work nearly as well.
Interesting.
And so it's just an example of we're beginning to understand more. Okay, we understand that,
The biology more, right? The phage biology more.
but at the same time, in the same thing, you know, we've learned that an inoculated tree doesn't work for trials, right?
Yeah. Yeah.
That we know. That's a big difference from a few years ago.
Okay.
We don't yet know why. So when you do the swab, when you do the everything,
Yeah.
it looks the same, but it clearly isn't.
Yeah.
And I think that this is what we're going to learn more of in the next 5 or 10 years. I give an analogy a lot of times in terms of our body. We are 30 trillion cells of us, we're 33 trillion bacteria, we're 300 trillion virus.
Yeah.
We can kind of understand how these things work individually. But as a system,
It's complex.
it's very complex. We really don't understand yet.
Yeah.
We're not close to understanding.
Yeah.
And so when it comes to any biology, with AI, with advanced science, with all these things that we're starting to apply, we're learning a lot more fast.
Yeah.
But there's also, the more we learn, the more questions
Will
we
come
sometimes
out,
have.
Come out. Wow, that's the learning. Yeah.
But where I think that we will begin to really see some change is that we look at this as a tool.
Yeah.
If you try and sell the farmer on the concept that this is great, you should get rid of your other things, maybe it's true, but no farmer can accept. The risk is much too high.
Right? Yeah. Yeah.
What farmers can accept is taking a phage and making it part of the IPM program. So you have, before you had your hammer, you had your wrench, you had a screwdriver.
Yes.
Okay, they can accept adding a tool. And they may use the screwdriver more than the wrench.
Yeah. So eventually, maybe
Yeah, but it's step by step, and they need to see it work. They need to de-risk. They need to do all of these sorts of things. And so it's a great tool. And I think what we will learn in the next 5 years is how to use our tool with the rest of the toolbox better. Where do we get benefits by putting two products together? You know, can the farmer spray two things at once?
Yeah. Yeah.
What is the correct combination of
Ending phage.
Yeah.
So basically, you are really not only on the technology part, it's also on the end user part. you just try to accumulate some of the knowledge. When you let the farmer to use, you give some data. Look, this is what you will get.
I think that that's the same with every product in the world. You have to understand what the buyer wants. You can't give them what you want to give them. You have to give them what they want to buy.
Yeah.
And when you're talking about new science, neither side really understands it yet. What does the buyer want? Well, clearly he wants to get rid of the bacterial disease. But how does he optimize that? And that's something that both sides learn. And I think we'll be much more advanced 5 years from now to be able to really optimize how our product can be used in the fields by the farmers.
Yeah. But maybe this, you already answered my question in your talk is, I think it's 2008, EPA has approved one feed product. Until 2017 or something, very successfully, either feed trials or feed
it wasn't really until 2019 that we did the first large-scale trial that showed not only about disease, but also about improved yields. And improved yields is, farmers care a lot about that. You know,
yes.
For 100 RMB, what do you get in return? If you get 150 in return, you're very happy. If you get 80 in return, the product is never used again. And so this is what we see is, and it makes common sense. When we use a phage as compared to a chemical, we get much less phytotoxicity. We get much less damage to the biome around the root system, around the rhizosphere. And that naturally means that you got a healthier plant, and with a healthier plant, you get increased yields. Typically, as compared to a copper, we'll get between an 8 and a 14% yield increase. So it's not inconsistent. It's not small.
Because, like you mentioned, the biology, it's not giving stress to plant. Right. This is benefit to plant, not stress them.
Right? You know, we show up at the apple orchard, and all the trees are smiling. You know?
So I know citrus greening is the one disease important to all over the world, right? Especially Florida. So I know bacteria cannot be comfortable. Hopefully someday, the phage, can really.
Yeah, it's a different disease, and it's actually, in a lot of parts of the world, less of a stress on the citrus than citrus canker is. People always thought that the greening would be the worst of the problems. But it's not that easy to transmit from tree to tree. And what we've done is we've concentrated on eliminating the insect that transmits. So it's become less of a problem over time. Whereas the citrus canker, this is so easy to transmit from one to the
tree
next.
To another tree, and spread out if it's a hurricane in Florida. Right.
And so it's not just about the pathogen itself, but the life cycle of the pathogen. And for some, we see very easy, very rapid spread around the globe. We see very quick mutations. So there's in shrimp, as an example, there's parahemolyticus, and this changes so easily that it's almost like the flu. Every year we get a new flu vaccine because it changes very quickly, and so you've got some pathogens that change very quickly, some that do not, and a number of the ones in plants are kind of in the middle.
Okay. Well, thank you very much. One last question, Mark. So you are entrepreneur, right? And having business for so many areas, more than over 30 years experiences. If you may give a young entrepreneur who come into agriculture, biotech, wanted to develop a biological solutions for farmers, what insights or suggestions or advice you will give them they should be aware?
Well, my grandfather told me that there was one key to being a good entrepreneur, and that was to be so stupid you didn't know you were bankrupt.
Okay.
And I laugh at that because every young business struggles day to day to pay the bills.
Yeah. Yeah.
And what it really means is that as long as you're passionate enough and you continue to put one foot in front of the next foot in front of the next foot, that the passion very often drives the success.
Gotcha.
And you know this with the people around you.
Yeah.
If they're passionate about something, you want to support.
Yeah. And they just move by themselves.
Yeah.
Right? You don't need to push or do anything.
No,
Yeah.
So money is often the least important thing.
Yeah.
It's the driving towards a real goal that they're passionate about.
Yeah.
The other side is I have rarely seen people that are driven by money
Which is
be successful in their business. When I go back to the bees on the farm, this is what makes me really happy.
Yeah.
Not a new registration, not a, but seeing a farm that has now the potential to be transferred from father to son in a better condition than the father had it.
Yeah.
This is sustainable long-term farming, and this is what we need to really feed the world as we continue to grow the number of people.
Yeah.
And for me, this is very important. I'm a passionate conservationist, and so I want to limit the amount of damage done to
nature.
To nature, yeah.
Yeah. Well, thank you very much, Mark. I think I believe our audience will also learn from Mark the very insightful comment suggestions, and especially the phage technology. To be honest, I'm very excited to see how this technology can.
We're excited to see how far we can take it, how much we can learn in the next 5 years.
Yeah. Well, you guys are the leader in this space, and I will wish you guys continually to push the boundaries, like you mentioned, but driven by passion, right?
Yeah. If you're not happy seeing the bees, this is not the business for you.
Wow. Thank you very much.
Thank
Mark.
you.
And all right, guys. I hope you enjoyed this episode. And if you have questions, I will put Mark's company information, the link underneath this channel. And thank you very much.
Thank
See you
you.
next time. Bye-bye.
Bye-bye.
Bye.